To me, research-led education means in part that the people that are teaching are also active in research, and that includes me. So I hope that my enthusiasm for my teaching is fueled by my enthusiasm for the research that's related to it. So I think we should check with the students, but I think the students benefit from that, which is actually having researchers, active researchers, teaching. And quite often that also has sort of tangible aspects in the sense that I might even share a problem with them that I'm working on now or that I think I've just solved, partly because that's very fresh in my mind, but partly because actually we can get them to help us with our research, you know, these bright people. Second thing is, when I'm teaching, I would like the students to have some knowledge, of course, some specific knowledge about my subjects. I love my subject area. But more than that, I want them to sort of, I want to engender in them that sense of joy at finding new things out. And that's where the research element comes in. So rather than, here's a load of stuff you need to know, get your exam, stock it away, never use it again, what you really want to do is engender some spirit that goes way beyond the subject, which is about recognising that most things we don't know, which means that they're open playing fields and that people can contribute to them. And that if you have the right skill set, you can actually ask questions almost every day that potentially you could answer and be the first person to answer. So that notion of research as a joyous activity, you know, of learning more generally as a joyous activity, I think that's the thing you really want to get across.
I think for me, how I interpret research-led education is, first of all, when I'm in a class, I would always try and work in something that only I could tell you. Because I think that's what's important about when you're a researcher, you are making the subject. So that's what should be different. When the researchers are really right at the front of the subject, they are, you know, literally making it. So I would maybe talk to my first year mineralogists. When I introduce what a mineral is, I would talk about my role with the International Mineralogical Association and about how you can propose a new mineral and the committee that will approve it, and about what the new minerals might be that have just been proposed. So to actually bring people right to the front of the subject. And when I teach second year igneous petrology, I'm sure it's very obvious when I teach the lecture which is on my own research, and I'll say this is what we're doing now and this is what we've just found, and maybe bring in a PhD student or somebody to give a lecture as well, so that they can see that it's a real active subject and that things are changing. And I might talk about what they can read in the textbook and how that's already wrong and that we've moved on to the next idea.
I think there are two distinct angles on research-led teaching. The first is the pioneers, the people at the frontiers of research, bringing their work into the classroom, discussing it with students, making it real for them, and thereby inspiring the next generation of scientists, engineers, mathematicians. The second angle is ensuring that our students have the opportunity to engage in research-like processes. So as an example, I run a first year mathematics module where we get the students to work in teams to look at various aspects of their discipline, certain topics such as cryptography within there, but also wider questions such as what part of a community am I involved in? What is a mathematician? And we get them to do surveys with each other, to interview staff, to interview postgraduate students and compare their findings with national survey data. So they start to get an understanding of the community of which they're a part and are engaged in those quantitative and qualitative research methodologies that we would expect of researchers.
Well, I think the great thing about research-led teaching for us is that it allows us to bring together the two things that we do as academics, research and teaching. And this is, in a way, a bit more exciting than standard textbook maths, where someone gives you a problem to which the answer is known and you have to go away and figure it out. The point about research, of course, is that you don't know what the answer is when you begin. So someone might give you a load of data to analyse and nobody knows what the answer is. It's up to you to formulate some questions, test them, see if you can get a coherent story out of the data.
I always get my students, my project students, involved in real-world research projects. And those research projects are all on real-world problems. So they're all addressing particular problems in industry right now. And I'm normally doing a research project on that here, and I'll get my undergraduate or any other students involved in those things. And the students find it really satisfying to see the broader question, the broader problem, and feel like they're taking part in it. And they're often very capable of tackling research projects with a bit of direction, of course, but they're usually very capable.
Basically, I link research to practice. So when we come with a practical problem, we need new ways of solving that practical problem, and that's where research comes in and trying to improve solutions, and then that feeds back into our teaching. That's the main reason why most of us want to be involved with practice, with the industry. Industry brings new problems to us. That's new research kind of directions and focus, and then from that it has to kind of spill back into teaching, because we can't teach on only on historical problems. What was the problem in the 19th century has been long resolved, and we have to grapple with today problems.